We had a few. I want to go ahead and start from the 1.7. I think we had one that we didn't do yesterday. I'm not sure, but y'all can tell me if we did this one. I thought we finished all 1.7, but did we do this one? Yes or no? Yes or no? Thumbs up or thumbs down?
I don't think so.
I don't
Okay,
believe
we'll do it. All right, here we go. So it says find the derivative in respect to x. Find dy dx with y is equal to 1/2 u to the 1/2 and u is equal to x squared plus 6. Okay, this does us no good. This does us good. In other words, we want this guy, we want to take the derivative of this guy in respect to this guy. But the problem is, this guy is in the way. So we got to get rid of that u. So we plug and chug. Y is equal to parentheses to the 1/2 power, and plug that x squared plus 6 in here. And now we can take the derivative of y with respect to x. And that's what this means right here. So that's going to be y prime 1/2 x squared plus 6, 1/2 minus 2/2. And then what do these pink parentheses mean? I got to take the what?
Derivative.
I got to take the derivative of what? What's
The x.
What's inside? And what is the derivative of x squared?
2x.
And I'm going to put a 2x right here in green. And now I'm ready to put it all together and simplify. So I'm going to put a baby step in here for you. Y prime is equal to 2x over 2 x squared plus 6 to the negative 1/2. And the 2 and the 2 cancels. And you could bring this downstairs. So y prime is equal to x over the square root of x squared plus 6. And you can rationalize the denominator. If you rationalize the denominator, you would get x times the square root of x squared plus 6 over x squared plus 6. So one of those two answers is going to be your answer. Give you a second to let that. These are your two possible answers. Not simplified, simplified. Actually, this one's more simplified, but since we have this little thing about radicals in the denominator, we do this. So let's go and see which answer they want. I'm going to type in 3. There's the answer. So they did not want it rationalized. So you need to make a note that when you're doing a problem like this one is your answer. Okay. Now that takes care of 1.7 questions. That's all the 1.7 questions that we had. Now I'm just going back on the 1.5s. Usually the 1.5s, usually people hang up on them because they're applications, that's all. Let's see, what does this one say? Okay, in 2 years, the population grows 800,000 to a size of P. So population is equal to blah, blah, blah. They're going to want to go ahead and find the derivative of that. So let's write down that function. And that's going to be P of T is going to be equal to 7,000 T squared, 7,000 T squared. I have no idea where, I don't know where this comes from. Writing that 800,000 first. This is the first or second year I've noticed that. It must be the Tide Pod, what is it? Tide Pod core, math core, or whatever it's called. What do they call it that they teach in school now? Common Core Tide Pod. There we go. That's the way you're supposed to write it. I don't know where the hell this comes from. Okay? I've been teaching for well past 25 years, and I have no idea, never seen this before until the last couple of years. How about y'all? Have y'all seen that in high school, writing them like that? Yes or no? Okay, so it's not me. So this is weird. Okay, because I've never seen that before. It's always been written like this.
Yeah.
All right, so P prime of T that's going to be 2 times 7,000 T to the 2 minus 1. Oops, x to the 0, and that's going to go out 0 times 800,000 x to the 0 minus 1, and of course that goes out. So you're left with P of T, P prime of T is equal to 14,000 T period. So basically this is your slope slash rate of change or rate of whatever. And this is your population. Because what they do is they ask you the next question and you think it's plugging into this when it's actually plugging back into this. I don't know why they do that. So find the population after 15 years. So that's going to be population at 15 years is equal to 7,000 times 15 squared plus 800,000. And that's going to be 7,000 times 225 plus 800,000. And I have no idea what that is, but if y'all want to calculate it right quick, I need 2 people to verify it. So somebody crank that out.
It's 2,375,000.
2 million what?
375,000.
Okay, can somebody give me a thumbs up on that?
I got that
Okay.
too.
All right, so we'll type that in as an answer. Now they want to know the growth rate at, I don't know, 15. Let me see, make sure because I don't want to assume anything on these. Yeah, 15. So we plug that into, so I'm going to do that right here. P prime of 15 is equal to 14,000 times 15. Somebody give me that number, please.
210,000.
210,000.
I think.
Somebody give me a thumbs up on that one. Okay? So at 15 years, the population is going to be 2,375,000. And at that point, it's growing at 210,000 per whatever year or whatever they said. Let's go back to the question. In T years, so per year. So dp dt is going to be 14,000 T. 14,000 T. And the population is 2,375,000. And the growth rate is 210,000. And they're going to say, what's the units? Well, 1,000 people per year or whatever. What is the meaning of the answer in part C? It's growing at 15, it's growing at 210,000. Tells the difference between the rate of growth of beginning 0 to 15. No. The growth rate tells which population growth at T is 15. I believe it's delta, but this is one of those Philadelphia lawyer questions. So it might be Z for all I know. There we go. I like that question as far as a test question. I just don't like D because D, I don't like when they ask these questions because they try to confuse you. But the previous three, I like A, B, and C. Next question. That's 91. So hopefully Miss Megan, Miss Gammon, and Miss Brody, y'all good? On 91? I don't know about, okay, I'm sorry. Gammon, yes. I didn't see you, I'm sorry. Gammon, Megan. Okay, you got one of those names that I totally just, I don't know. I'm just gonna say Megan, okay? I can't tell which one's first and which one's last. So, Brody, you good on that one? Brody done left. She just got tired of it. She just left. I don't see her anymore. There she is.
She got sick of you.
I don't hear anything.
Is it frozen?
I think so.
Did he leave us? Shit, he left us. He went to go get milk. I'm sure we'll see him again. Never comes back.
I don't know what the heck just happened. I think Teams. I
was having a
believe
really
they're
hard time logging in.
Did anybody get a message on your screen or anything?
No. But
I just
had
got
to
you
leave.
have a meeting on another device. Would you like to join that meeting on the other device?
Mine just
What
said
other
that too.
device?
Mine said that too.
The damn Russians is what it is.
Yeah, I had a hard time getting on here today. It was really, really slow.
It is the Russians and the Ukrainians. They're coming to take over the U.S. since they bought off. Oh, shut up. Way to go, Hunter.
Yeah, Hunter's.
Way to go, Brandon. Way to go.
Let's
All
go,
right.
Brandon.
W of T. Let's go, Brandon. Let's go. equals 9. Okay, we're not writing it like that because it's written backwards. So we're going to write. Can y'all still see my screen?
No.
Can y'all? You're kidding.
I have Braden, Bennett, and Nina on my screen.
All right, I'm sending it again.
Sorry to whoever's screen I'm on.
Can you see it now?
Yes.
Okay. W of t is equal to 0.000674 t to the third minus 0.0058 t to the second plus 1.35 t plus 9.89. Okay, the median weight of a boy whose age is between 0 and 36 months can be approximated by this function. Okay, so I guess t is time, I guess in months, and of course W is t. I mean W is weight. What does the question say? Where t is measured in months, okay, and W, Clemson, is measured in pounds. Use this approximation, blah, 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 blah. I'm going to go ahead and find the derivative because we are in the derivative section. So I'm going to need some, no, I better do it myself. No offense, but sometimes y'all lead me astray and don't tell me the right answers. So I better get my calculator going. And then some of y'all don't know how to use a calculator, so I better just do it this way. Wait for my calculator to come up. So that's going to be W prime of t, outside, inside. So 3 times 0.000674 t to the second minus 2 times 0.0058 t plus 1.35. So there's the derivative. Now I take my handy dandy calculator. Take my handy dandy calculator and I take 0.000674 times 3. 0.00202. Somebody check that, please. 0.00202, and just say something if it's not correct. W prime of t, 0.00202. Okay, my computer just flashed and y'all disappeared, so I don't know what happened there. All right, so 0.0058 times, excuse me, 2. I got 0.0116 minus 0.0116 t plus 1.35. So we've got two formulas here. We've got the equation for the weight, and then we've got the rate of change at a certain point, which is that one right there. So chances are they're going to say, what is the weight of the baby at 3 months? And what is the rate of change of the weight at 3 months? That's probably going to be something like what they're going to say. So let's see what they're going to say. The rate of change of weight with respect to time is that what we just did. Point 0.02022 0.00202 plus 0.116 0.0116 plus 1.35, Okay, the approximate weight of the baby at age 14 months, the weight. So the approximate, so B is going to be W of 14 is equal to 0.00674 14 cubed minus 0.0058 14 squared, just bear with me a minute, plus 1.35 times 14 plus 9.89. And I need somebody to be calculating that, please. Because I'm not going to do all that with the mouse trying to, And then they're going to say, what is the rate of change at 14 months? C, the rate of change at 14 months is W prime of 14, which is going to be equal to 0.00202 14 squared minus 0.0116 times 14 plus 1.35. And I need somebody to do that one for me. So if somebody got this one, give me a weight. Let's round it to the hundredth. What do you get here?
18.49.
I'm sorry, what?
18.49.
Yeah, I heard 0.49. I didn't hear. Thumbs up or down? Thumbs up or down on that one? I'm looking for somebody to confirm that. Okay, I see one person. Thank you.
I got 46.15.
I'm sorry, you got what?
46.15. But I'm
Okay,
double.
All right, we got one person confirming 18. And Mr. Lynch, what did you say you had? I couldn't hear you. Yeah, his microphone is still muted. Okay, 46.15. All right, somebody confirm which one is correct. I got two people saying 18.49 and one person saying 46. So somebody confirm, please. Leave the cat up there. He can stay. The cat can stay. 46.15. Anybody? All right, we're just gonna type it in because I'm not gonna spend the time to do it. It says 2 decimal places. Let's go with 18.49. That's incorrect. So let's go with Mr. Lynch, 46.15. And that's incorrect. Y'all suck. Try it again, somebody. I'll tell you what, let me just hit 3 and let's see what they get. They got 29.5. Did somebody get the second part right here?
I got 1.21588.
For which part, B or C?
C.
You got what now? Say it again.
1.21588.
Okay, can somebody confirm that one? We got a lot of people in the class that aren't doing
Oh, no, I messed it up. I didn't square the first 14.
All right, can somebody confirm or get another answer or confirm 14? B, is that answer right there? Can somebody confirm that? Because we didn't get nowhere near that, and I know mine's not off that much.
Yeah, I didn't square the first 14. I'm redoing it.
Okay, you're doing the second one, or are you talking about B or C?
C.
Well, the first one we left out a 0. Okay, 064. Thank you, Mr. Lynch. So, yep, right there. So let me check that right quick. Calculator, 0.00674 0.0674 times 3. No, we got a 0 right there. 00202. 00202. Doesn't matter if it's after the 2. I think that one's right, but let's see what the third one is. I'm not gonna. I've done the for B to get to 29.5. Well, okay. Well, I don't know. I'm just gonna. I showed you how to take the derivative. I don't want to spend a lot of time on it. 1.58, is that what somebody got? Everybody's going to say, yeah, that's what I got. Okay, so we did get this right. We got that right. 0.00202. And yeah, we got it right. Just plugging in is what got wrong answer. Thank you, Mr. Lynch, Miss Kelly, and whoever else that was helping. Thank you. All right, next. Next question. That's 87. 76. 76.25. If 1.5 is 76.25. For the function, find the points on the graph at which the tangent line is horizontal. If none exist, state the fact. All right, y is equal to 1/3 x to the third minus 5x plus 4. Okay, so first of all, the first thing I'm going to do is graph it. We know it's a cubic function, and we know that the y-intercept is 4. So with that being said, let's graph it. Y is equal to 1/3. Well, I better put that in parentheses. 1 divided by 3 x cubed minus 5x plus 4. And turn my stat plot off. Hold on, guys. And zoom standard. Oh yeah, we got 2 places at the vertex. We got to find those 2 vertexes. So I'm going to just, and we haven't find, you take the first and second derivative. The first and second derivative will help you with that, but we're not going to do that. We're going to take the calculator. And we're going to do a second trace. And 1 is the maximum. And I'm not going to zoom all that. I'm just going to give it a left. There's the left. There's the right. And then I'm just going to go up there and hit enter. All right, so there is the one there's one place at the horizontal. X is equal to negative 2.23607. Y is equal to 11.45356. And the other one, second trace minimum, and there's the left, and there's the right. 2.23607. And a minute for that to happen. And this is going to be about the same probably. Nope, negative 345, negative 3.45356. Now, those are the points where they are zeroed. So let's see what else they want. I don't know. The points at which the tangent line use radicals. Okay, they want to use radicals. Yuck. They are going to have to use, they're going to have to use the derivative, first and second derivative. Oh, I know what they're going to do. They're going to set the slope equal to 0. That's what they're going to do. All right, that's what we'll do then. I know what they're doing. Okay, so we're going to take the derivative of this guy. This is by the calculator. They don't want that. So take the derivative of this guy. Y prime is equal to 3 times 1/3 x to the 3 minus 1 minus 1 times 5 x to the 1 minus 1 plus 0 times 4 x to the 0 minus 1. Oh my God, I just X'd out of that. Can't believe I just did that. I think it's about time for me to just quit and start drinking. Maybe that's what technology is trying to tell me, but I just need to quit. Y prime is equal to x to the second minus 5x to the 0. So y prime is equal to x squared minus 5. Everybody with me? Now, that is the equation for the slope of the line. If I want to find out where the slope is equal to 0, I set this equal to 0. So x squared minus 5 is equal to 0. X is equal to positive 5. Take the square root. X is equal to positive or negative square root of 5. Now, I don't know if they want the y or not, but I'm going to say positive or negative square root of 5. Positive or negative square root of 5. Okay, they wanted all that trash. They wanted the x and the y. I'm sorry. Well, you plug in that square root of 5 into the original equation. Take this square root of 5 and plug it into this equation right here to get your y, because that's x. So knock yourself out. Plug in a positive 5 square root of 5. Plug in a negative square root of 5. You're going to get these two numbers right here. But okay, let's move on. That one is a good test question, but the answer, all they needed was the x's. They don't need all that. There's the positive square root of 5. There's the negative square root of 5. That's all they needed. How about 65? 65, 23. 1.5, 65, 23. For the function, same thing. F of x is equal to 6x squared minus 4x plus 4. Since they wanted it in radicals, we're going to do it with the derivative. 12x minus 4. 0 is equal to 12x minus 4. 12x is equal to what? 4 x is equal to 1/3. So at x is equal to 1/3, you have a slope of 0, which means it's a horizontal line. And again, if they want the x and y, which I don't know why they'd want that unless they just want you to do the work, you plug in 1/3, and that would be 6/9 minus 4/3 plus 4. And do that math. I'm just going to put in square root. I meant the 1/3. One-third. All right. Next. That was 65. This is 62, and that will complete all of our homework questions. So that is 1.5, 62, 22. Same thing. Y is equal. I'll do this one since it's shorter. I'll do this one and do the whole thing. X squared minus 5. So y prime is equal to 2x. I'm sorry, not 2 to the x, dork. 2x. And 0 is equal to 2x. X is equal to 0. Take that 0, plug it back in. Y is equal to 0 squared minus 5. Y is equal to 0 minus 5. Y is equal to -5. So there's a horizontal line at 0, -5. And that's how you do find the x and the y. Find the x with the derivative, and then you plug that answer back into this to get that right there. So 0, -5 should be your answer. And I better put parentheses around it or it'll have a conniption about that too. All right, that's all the questions. Does anybody want me to go over another question or finish one of those that needed plugging and chugging? Or does anybody have another question? Or speak now, forever hold your peace. That's all the questions. 6.2. I think that's it. All right. So let's look at new material. I mean, I wish I could let y'all go, but I need to at least go over new material so you can be looking at it over the weekend. All right. So here we go with new material. First of all, let's go over a couple of things before we go over new material. First of all, you got to remember your exponential laws, which is the power rule. X squared times x to the third is equal to x to the fifth. You got to remember your quotient rule. X to the fourth divided by x to the first is equal to x to the third. You add, you subtract. Power rule, x to the fourth times 3 is equal to x to the 12th. You got to remember that you can rewrite a negative exponent by flipping it. And you can rewrite a complex exponent, x to the fourth over y to the fifth raised to the -4th power. You can flip what's inside and the negative becomes positive. So there's your 5, really 6. There's one more, and that is the square root of x to the first power is equal to x to the 1/2. You put your exponent over your index. And one more, and I show this one usually when we get to logarithms. X to the 5th is equal to x to the 8th, x plus 2. And what happens if you have the bases are equal? What can you do with the exponents? Come on, algebra people. What can you do if the bases are the same? What can you do to these exponents? Set them equal to each other, Hubert. That's right. So 5 equals x plus 2. And x is equal to 5 minus 2 is 3. All right, so these are all your exponential laws that you need to remember. There's the product rule, the quotient rule, the power rule, the inverse rule, the inverse power rule, rational exponents, and exponential equalities. 7 exponential equalities. Okay? And usually this is a different exponent, so I'm going to make this a W. W plus 2. W. Okay? Clemson. So that's your exponential rules revisited. Your logarithmic rules, the definition of a logarithm. Y is equal to log base A of x yields a to the y is equal to x. That's the definition of a logarithm. You should not have forgotten that one. That one is detrimental. Power rule or product rule, log base 10 of x, y can be rewritten as log base 10 of x plus log base 10 of y. That's called the product rule of logarithms. Log base 10 of x divided by y can be rewritten as log base 10 of x minus log base 10 of y. Power rule, log base 10 of x to the 3rd power can be rewritten as 3 log base 10 of x. The change base formula, log of 7 of 9 is equal to log of 7, log of 9 over the log of 7. And that's base 10 or base E, either one. In other words, if you're given a logarithm to a different base than the calculator can do, which is anything but 10 and E, then you have to put it over itself. So 9 over 7. Remember that your calculator can only do log base 10, which is log, and log base E, which is what? Natural log. So if you don't have log base 10 or log base E, you've got to change it, and that's the change base formula. And that kind of gives you some summary or review of your logarithmic properties. So now let's go to logarithms. Oh, before I do that, I want to do one more thing. I want to talk about inverses. Inverses. Inverses mirror image. When you're on the graph of the mirror image, in other words, y is equal to x squared, goes this way, square root of x goes this way. Mirror image going in the opposite direction. These are inverses of each other. Graphically, you can usually tell with a 45-degree angle because they're the same on one side as the other. Okay, this is called an inverse. So y is equal to x squared, y is equal to square root of x. They're inverses of each other. What is inverse? Well, let's say that you got a point here, 3, 9. The point down here will be 9, what? 3. That's what makes up an inverse. The x and y on the first one is usually the y and the x on the second one, or vice versa. X, y, turn it around, x, y. Okay, so how do you tell the inverse with algebra? Well, let's say you're given y is equal to x squared. F of x is equal to x squared. Well, the first thing you do is you use x's and y's. You use x's and y's. So get rid of that. Get rid of that f of x. It's like a chrome-plated. It's kind of like a chrome-plated handgun. Sissy pistol. Okay. So get rid of the f of x. Change it to a y. Speaking of weapons and terrorism, I found a clip to one of my guns yesterday. I cleaned out my truck and it was under the seat. So now what do? Switch.
Load it. Oh.
Nothing. Be quiet. Don't say that. You'll offend someone. Switch X and Y. Remember, cars kill people. All right. So switch X and Y, so you get X is equal to Y squared.
McDonald's makes me like that.
I want to ask one question. Who do they put on trial when it's a drunk driver and he kills the family with his car? Who do they put on trial?
The CEO of the car company, right?
Who do they put on trial when somebody bombs a building?
The bomber.
The guy that makes the bomb.
Yeah.
Who do they blame when somebody shoots somebody? The gun.
Yeah, they don't like they try to defend the shooter. Oh, he was disadvantaged. Oh, he was. No, I'll be quiet.
Yeah, be quiet. I just wondered, knives kill people.
Knives kill more people than guns do.
All right. So, and now solve for what? Solve for y.
The murder. Oh, I thought you were going to say
so square root, y inverse is equal to the square root of x, and that's what we said up here. Again, this is review. You should be saying to yourself, oh yeah, I remember that. Okay. It's just a little review. And now I'm going to give you the 4 or 5 rules, and I've already given it to you. So I'm just going to show it right quick. And I sent it to y'all. There's what we just went over. We just went over this. And there is your rules for the next unit. Now, I want you to be careful here, because that e to the x is a little bit misleading. What do you mean? Well, I want you to write f of x is equal to e to the 1x and put parentheses around it. Now, this is something you need to get in the habit of doing, because you got to remember our friend. What rule do I take a pen and do this with? What rule of derivatives do I do that with? It's not the product rule.
Quotient rule.
It's not the quotient rule.
The chain rule.
The chain rule. So go over here and say, remember the chain rule. And I will get, if I give the whole class a test, and it has 10 questions on it, and I put e to the x, and I put e to the negative 4x, and I put e to the 2x, half the class will get 2 of those wrong. They won't get the first one wrong because they go, oh, e to the x is e to the x, no matter what you do. But I don't want you to learn that. I want you to learn the chain rule with e to the x. So the derivative of e to the x is whatever it is. But you also got to do the derivative of what's inside. Now watch what happens. F prime of x, bring that down. And then somebody tell me what the derivative of 1x is.
One.
1. So now I rewrite it as f prime of x is equal to 1 e to the x, which is equal to e to the x. Now, why do I want you to learn this? Because if I give you this on a test, which I will, y'all will get it wrong. Now, this is a class with, how many is in here right now? This class has 22. I would say 10 people will get this one wrong. Why? Because they just think the derivative of e to the x is e to the x, and they write e to the 3x. It's not. Take our handy dandy highlighter. And the derivative of e to the 3x, f prime of x, is equal to e to the 3x times what?
3.
I'm sorry. Articulate, please. I heard.
3.
3.
Yeah.
And that turns that into what?
3e3 squared.
3e to the 3x.
Yeah.
And if you put e to the 3x on the test paper, you got it wrong. This is a good habit to get into with your e to the x's. Here's another one that you'll get wrong. F of x is equal to negative e to the 1/2. Oh, I'm sorry, 1/2 x. So f prime of x is equal to negative 1 times 1/2 x e, I'm sorry, I just messed that up, I'm sorry. Negative e to the 1/2 x, and what is the parentheses? What is the derivative of 1/2 x? 1/2, and your answer is negative 1/2 e to the 1/2 x. Always remember with E, make sure you put this in parentheses. Okay, now let's look at, this is a power. Here is an example of a power. F of x is equal 2 to the x. That's what it'll look like. And they love to do 2 to the x for some reason. I don't know why, but they do. And f prime of x, you put it in 2 to the x, just rewrite it, times the natural log of what? Natural log of 2. Well, here, what if you have a 3x there? Well, let's see. F of x is equal to the 3x. Ooh, before I do that, I got to take my handy dandy highlighter. All right, now you do that one. Give you a minute. Shouldn't take you too long. So, f prime of x is going to be equal to 2 to the 3x natural log of 2 times what?
Three.
Times 3. So you would rewrite that as 2 to the 3x, 3 natural log of 2. And you need to put parentheses around it, or you can put a dot here, whichever one you want to do. That's how you do a exponent. Now, of course, you're going to see more of these. I'm just kind of giving you a little introduction. And here is the third one. Natural log of x. F of x is equal to the natural log of x. Or you could say the log, it doesn't matter. Okay? F prime of x, I'll put parentheses around this because it matters. So that'd be 1, let's see, that's equal to, let's see, x comes down, and then what is the derivative of x? 1. And that's how you get it. So the derivative of x is equal to 1. Now I'm going to write something out to the side. It's very important for you to see it. The natural log of, the derivative of a natural log basically is called du over u. Write that down because you're going to see that again. This is something you're going to see again. Du over u. And that is what this is. What is the derivative of x? 1. 1 over x. Gmail. So if I give you f of x is equal to the natural log of 4x Somebody tell me what the answer is. That means I want somebody to say something. Y'all are such a disappointment. What's the answer? Come on. I put parentheses around the 4x. The derivative of 4x is
4.
the derivative of 4x is
4.
4. Can y'all say 4? Y'all sound like y'all at a 4 over x. You say 4. You don't say
4.
there. Thank you. All right. And the last one. Right there. Write that one down. Log base a of x. This is when it's kind of a mixture between the derivative of the log and the change base formula. F of x is equal to log base 3 of 10. Well, f prime of x is equal to 1 over, let's see, what is x? That's 10. Well, let's go with, I'm sorry, x, 10x, sorry. Take the derivative of 10x, which is 10, natural log of 3. There you go. Now remember, whatever's in these parentheses is going to be right there. That's the derivative. Just like the chain rule. Question, gripe, complaint.
Nada.
All right, you still got a test to finish, and you got homework to finish, and you got this to start. So I'm going to call it a day. Let me go and see if I can pull up if they haven't logged me out, which they probably have. Let's see if we can